Okay, for my last video today, I'm going to do another example of a rotation using my same square. So remember, for a rotation, we're taking rotation, we are taking a shape and we are turning it around a fixed point. So we're turning it around a fixed point. We'd say every point turns the same direction and it will remain the same distance from that fixed point. So if you imagine the hands of a clock, our directions could be clockwise or counterclockwise. As my hand turns, every point on that clock is the same distance from the center. So it's turning around that fixed point, but it remains the same distance from the center. So let's look at some examples here. If I take my tracing paper and I lay it right over my original image, you can do this at home with just a regular piece of paper and just draw dark lines. Let's say I trace over my square, and I'm gonna call it L. I'm gonna do it yellow. Just do as perfectly as I can, right? L, M, N, O. Here's L, here's M, here's N, and here's O. And let's say that I want to rotate it counterclockwise 90 degrees. I keep my fixed point right in the center, and notice my shape is turning around that fixed point 90 degrees counterclockwise. So when I line it up, my new shape will be located right here. So notice what's different is my N has rotated 90 degrees and its orientation is now in the top left. My M has moved down, my L and my O. So notice that I'm going to label these prime. But notice how the shape is turned from its original image. Let's do that again. But this time let's rotate it 180 degrees. So I take another piece of tracing paper. I'm gonna lay it right on top of my other ones to the best of my ability. Close enough, right? I'm gonna trace this one in green. So I'm gonna take my same square, L, M, N, O, trace over it so I can see how it changes as we rotate it. I'm gonna go counterclockwise. This time I'm gonna rotate it 180 degrees. So notice my fixed point's right there in the origin. I've just rotated it 90 degrees. Let's keep going 180 all the way around. So that's a 180 degree rotation right there. So if you notice, again, my points are in a different orientation. My L has rotated over here, M, N, and O. We'll call these double primes, okay? This is one method on how to rotate an image around a fixed point 90 and 180 degrees. So we can check our answers another way using another method, which is using a ruler and a protractor. So what you would do here is you would actually connect each fixed point to the origin. Let's just do the 90 degrees, for example. So I could connect my fixed point O to my origin. And I know that I'm rotating it 90 degrees counterclockwise. So it should make a 90-degree angle and connect the same distance here and here. So let's check that with our ruler. So if I measured my ruler, my line from O to the fixed point is 1, 2, 3, 4, 5 units. Same thing here, 1, 2, 3, 4, 5. It's 5 units, it's the same distance. Do the same thing for L if I wanted to check that. So I can check my distance L just by connecting it to the origin. And let's say that I want to check my 180-degree rotation. this time. So we know that my 90-degree rotation is correct. So let's check my 180 degrees. If I used a protractor, I would know that 180 degrees is a full rotation like this. So it's just going to continue forward on a straight line. So I'm going to use a ruler to make this a little bit neater. So that my L should fall along this line, which it looks like it does, perfectly. And the measurement from L to the origin is about 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 units. So my L prime prime should be 10 units too. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Perfect. So you can see that from another method, we could just use a protractor and a ruler, and we can measure the distance from each point to its fixed point, and we can rotate it that way. The easiest way to do that is with tracing paper. And there you have it. So that is how you can rotate a square both 90 degrees and 180 degrees counterclockwise using tracing paper and a ruler and a protractor.